Now for question 4, we have this hydraulic cylinder CD is welded to an arm which rotates clockwise about A. Alright, so it will rotate about A at a constant rate of 2.4 radian per second in a clockwise direction. Knowing that the position shown, the rod B is being moved towards the right at a constant rate of 35 mm per second with respect to the cylinder, determine the velocity of point B. So first what we can do is we write down the general velocity form. So that will be velocity of B equals to velocity of B respect to the frame plus velocity of B prime. So attach a frame onto this rod CD, okay, this rod CD, and we were only measuring the linear motion. Alright, and this is what we get. Velocity of B respect to the frame will be 375 mm per second in the positive I direction because it's moving towards the right. Omega will be negative 2.4 radian per second in the K direction because it's moving clockwise. So clockwise it will be a negative value. Alright, so to find out VB prime, we need to get omega cross with the position vector of VB prime with respect to the absolute frame. However, we do not know the length, but we can find out very simply over here through Pythagoras theorem. Okay, so very simply I can find out that RB from A is 312.8, and I can find out this theta over here, this angle will be 36.943. However, that's not enough because we are measuring from the positive x-axis, so we need to add 180 degrees. Okay, so I add 180 degrees, and then I put in the values that I have right now because I know what's VB from F. I know what's VB prime because I got the values over here, and very simply I can find out that my VB will be equals to 604.765 mm per second in the 97.197 degrees direction. And why is that so? Because we realize that our I and J components, our I components is in the negative and J is in the positive. Hence we are expecting in the second quadrant. Hence it has to be more than 90 degrees and less than 180 degrees. Okay, so you just draw the vector over here and you will find out why it's 97 degrees. Okay, so that's the velocity of B, and that's the answer for velocity. Next, we're trying to find the acceleration of B. So acceleration of B can write in the general form, that be acceleration of B with respect to the frame and acceleration of B prime plus the Coriolis acceleration. We know that it's moving at a constant rate towards the right, so acceleration of B with respect to the frame goes to 0. Okay, so what's acceleration of B prime? Just imagine I glue a sticker over here and I fix the length, and it will only move in a circular motion. Get it? So what I have is, since it's moving at a constant angular velocity, there will be no tangential acceleration, and hence it's a circular motion only. There's no Coriolis acceleration and there is no linear acceleration of B prime only. Okay, so B prime is just centripetal acceleration over here, and then for Coriolis acceleration, I just need to imagine there's no structure. Give me a while. So I just bring this towards the front. No, sorry. Yeah, send back. Bring front one. And just imagine chapter 1, movement of a particle, kinematics of a particle. So I just need to do my omega cross with the velocity vector, and we find out to be in direction of 270 degrees. Okay, just do your right hand rule, because we know that omega is negative, so your thumb should be pointing into the paper. The velocity vector should be pointing towards the right, and you realize that your middle finger is actually pointing downwards. Okay, so just do your right hand rule. So omega, your thumb pointing into the paper, index finger pointing towards the right, and you realize that your middle finger is actually pointing down. That's why it's 270 degrees. Okay, so very simply I can solve for the acceleration of B, and the acceleration B I find out to be 1608.687 in the negative 26.473 degrees direction. So that will be all for question 4.